In this video, I'm going to be talking about conditional statements. And a little bit later on, we're going to be looking at related conditionals, which is taking a conditional statement and tweaking it in some way, moving different parts around with it, just coming up with other ways that we can actually write the conditional statement. So what is a conditional statement? First off, it's a sentence. That's all it is. It is a sentence. Now, it has a very distinctive structure that it is written in. It has two parts. Those parts are going to be called the hypothesis and the conclusion. It has two parts to it. Those two parts will also be separated by a comma, just to give you an idea physically what it's going to look like. The hypothesis part is going to begin with the word if, okay? And the conclusion part is going to begin with the word then. So you're going to have a sentence that we call it an if-then form. We call it an if-then form. That's our conditional statement form. In if-then form, it begins with the word if, and then the information that follows that is going to be called the hypothesis. You'll have a comma, the word then, and the part that follows after that will be referred to as a conclusion. The way that we use conditional statements, the hypothesis part is going to set up some premise. It's going to set the stage for something. It's going to identify an object. It's going to give us something. The conclusion part is going to be an idea that follows because of that premise that we have in the hypothesis. In example one, what we're going to be doing is taking regular sentences. All birds have feathers. Two angles are supplementary if they are a linear pair. We're going to take two regular looking sentences and we're going to write them in the if-then form. That means convert these into a conditional statement. Okay, so we've got an if part, which will be a hypothesis, some premise that we begin with, and then the second part, the conclusion, is a result that we can draw from that premise. Okay, for the first, what we want to write is, if it is a bird, comma, if it is a bird, then it has feathers. Okay, for the most part, it looks a lot like how this sentence is written. We begin with birds, and that is part of our hypothesis. We just start the beginning this way. We say, if it is a bird. Okay, if it is a bird instead of all birds. We say, if it is a bird, then it has feathers. And by the way, having feathers is part of the definition of being a bird. Anything that has feathers would be considered a bird. All right, two angles are supplementary if they are a linear pair. Notice that we do have the word if a little bit later in the sentence here. If that occurs, you should go ahead and make note of that and allow whatever's following that to be the hypothesis. Most of the time, that's going to work out for you. Okay, so what we can write is if, now I am going to go back to the beginning here and say if two angles, okay, I really want to identify what I'm actually talking about here. If two angles are a linear pair, then they are supplementary. All right, and that is a true statement. If two angles are a linear pair, then they are supplementary. Let me give a quick little sketch of what we're talking about here. This would be a linear pair. Okay, there are two angles, let's call them 1 and 2. Two angles that are adjacent to each other, and when you actually pull them together, they make a straight line which would measure 180 degrees, and two angles that add up to 100 is supplementary angles. That's what they are. Okay, now here's an interesting thing about conditional statements. You do have to be careful in the order that you wrote them. You're going to notice that in the second one, I did write it backwards, and I gave an idea of why I did that because of where the word if was already in the sentence. But in some cases when you write conditional statements, there's a direction that you can write it where it's correct, and there's a direction where you can write it where it is wrong. If I took this second one here and actually wrote it in the order that I see it here, and maybe wrote it this way, said, if two angles are supplementary, then they are a linear pair. If two angles are supplementary, then they are a linear pair. That would actually be a false statement. That is a false statement. Not all supplementary angles are linear pairs. We had talked about that previously, that to be supplementary just means that they have to add up to 180. So you could, look like under the circumstances here, two angles are supplementary. You can have two angles that are not adjacent to each other, which means that they are not a linear pair. However, when we flip it and we put the linear pair on the beginning part here, you actually do get a true statement. So that one works out. The other one about the birds and the feathers, in a way, having feathers is a definition to being a bird. So in that one, if you flipped it, it actually still stands as true. If it has feathers, then it is a bird. That would be a true statement. So we start to realize here one thing, which will pop up again in a little while, which is that if you're writing a conditional statement that involves a definition, those definitions can actually be flipped around. Now there's these other cases where we talk about an object and a property of that object. You need to make sure that you have the object in the hypothesis and the property as the conclusion. You can't use the properties to lead to that object. All right, for example 2, we're going to talk about negation. Okay, when we do these examples, we are not actually going to be writing if-then statements. We're going to take a little break from that, and then we're going to come back to writing the conditional statements while applying negation to it. So we just need to identify what that word actually means. The negation of a statement is the opposite of the original statement. It is the opposite of the original statement. Now, sometimes you're tempted to get really creative with how you do this opposite sort of thing, okay? But the way that we actually apply opposite here is either using the word not by just inserting that into a sentence or taking that word out of the sentence. That's all you got to do for negation. Okay, so our first statement here says, the ball is red. We don't need to think about what color is the opposite of red. That's not where this is going. All you have to say is that the ball is not red. The ball is not red. Statement 2, the cat is not black, okay? The negation to that will be the cat is black. Okay, so with negation, I want to be real careful with this. We define it as doing the opposite, Now in mathematics, the word opposite is usually reserved for the negative sign. Like 5 is the opposite of -5. -8 is the opposite of 8. Okay, and maybe that will help draw the connection here that when we negate these statements, it's almost like we're adding in a negative to things. Instead of the ball being red, it is not red. And if you already have a negative in there, you just take it away. So the cat is black. At the conclusion of example number 1, I was talking about how if we flip the statements around, they can either be true or they can be false. Okay, so conditional statements can be true or they can be false. Obviously, we want conditional statements that are true, but sometimes things end up being false and we need to be able to identify when they turn out to be false. To show that it is true, you have to prove that the conclusion is true every time the hypothesis is true. That's a huge task, and we're going to address it later when we formally talk about how to write proofs. So that's not going to happen in this video. We're not going to discuss how to prove that something is true. Okay, we'll handle it later on. However, we can talk about this. To show how it is false, you can give a counterexample. We have 3 related conditionals that we want to talk about. We've got the converse, the inverse, and the contrapositive. All right, now all of these are ways that we can take an original conditional statement, an if-then statement, and move some things around, negate stuff, and then create a new conditional statement. Now, sometimes when we do that, those conditional statements will end up being true, and sometimes they'll end up being false. All right, so what we're going to do is practice writing all 3 of these. The converse is going to be a switch to the hypothesis and the conclusion. Okay, whatever you had in the beginning part, let that go to the end. Whatever you had in the end, let that go to the front. You can think of the converse as reading the statement backwards. The inverse is going to be negating the hypothesis and the conclusion. Now recall that negating is either adding in the word not or taking the word not out. Okay, and you are going to do it to both the hypothesis and the conclusion. It's important that we know that it's always going to be both. We're never going to negate just the hypothesis or just the conclusion. All right, if you can do those 2, you can do the contrapositive because the contrapositive is the converse and the inverse. Now, most questions, you end up getting asked to do all of them. So we usually do them in this order. We write our converse, our inverse, and then the contrapositive. So If you've got these two done, you can easily do the contrapositive by either negating your converse or you can flip your inverse. You can flip that around. So you can look at the two that you've already built and easily write that contrapositive. If a question just calls for you to write a contrapositive, feel free to do a converse first and then negate that answer. Do it in pieces. For example 3, what we're going to do is take this conditional statement here. We're going to take that conditional statement, should be a little period there. Take this conditional statement and write the converse, the inverse, and the contrapositive. In addition to that, we're going to think about whether they are true or false. If they're true, we're not going to worry about really defending the answer. It just should make sense based on the context. Logical there. The false statements, we should be able to think of a counterexample that fits those. All right, our conditional statement says that if the measure of angle A is equal to 99 degrees, then angle A is obtuse. And that is true. Okay, obtuse is any angle that measures greater than 90, less than 180. So this is a true statement. The converse is going to be switching the hypothesis and the conclusion. So we're still going to write the word if at the beginning. That part's not going to move. If angle A is obtuse, then the measure of angle A is equal to 99 degrees. That would be our converse statement. True or false? That's actually false, right? Because an obtuse it's a range of values, greater than 90, less than 180. Yes, 99 is one of those, and that's why the original statement is true. But just because an angle is obtuse does not mean that it is going to be 99 degrees. There's a whole bunch of other options. 98 degrees, 105 degrees, those are all obtuse, but they're not 99. So this is false. This is a case where your converse ends up being false. Actually, in the front of this, let me write down at least this much. Converse. Okay. Next, the inverse. The inverse, you're going to go back to the original. Don't look at the converse right now. Go back to the original and negate those things. So we're going to start with if the measure of angle A, and it says here that it is equal to 99 degrees. The way that we can negate that is just put a little slash with the equal sign, and then it reads like this. If the measure of, oh, I forgot my A. If the measure of angle A does not equal, that's right there, does not equal, all right, if it does not equal 99 degrees, then angle A is not obtuse. Spell that one too. All right, true or false? If the measure of angle A does not equal 99 degrees, then angle A is not obtuse. All right, so if it is not 99 degrees, it's anything but 99 degrees. Does that mean that all angles that are not 99 degrees are not obtuse? No, 105 degrees. Okay, if we have 105 degrees, that would be something that fits the hypothesis. It is not 99 degrees, but yet it is obtuse. That is a false statement. All right, and then we have the contrapositive. I'll call that one CP, just to squeeze it in there. All right, the contrapositive. For that, we are going to do both. We're going to negate and we're going to switch things around. So what we could do, let's go ahead and take the inverse statement since it's right above it. We'll take the inverse statement and we'll flip everything around. So I'm going to say if angle A is not obtuse, okay, if angle A is not obtuse, then the measure of angle A does not equal 99 degrees. So I took my inverse and I used that to flip. Okay, I didn't really start from scratch on that one. All right, true or false? Angle A is not obtuse, so it is any angle measurement that is not bigger than 90 and less than 180. Okay, does that mean that angle A is not 99 degrees? Yeah, because we've took out that total range of values where 99 would sit. So that is a true statement. That is a true statement. All right, and fun fact here. If the original conditional statement is true. All right, if the original conditional statement is true, like I'm going to write that as a conditional. That's neat. If the original conditional statement is true, the contrapositive is true. All right, that is a neat fact. It's a bit of a hard one to prove, but it is a fact, and I'm going to share that with you. If the original conditional statement is true, the contrapositive is true. So it is possible that your converse ends up being false. It's possible that your inverse ends up being false. But if your original is true, your contrapositive is guaranteed to be true. Or if your original is false, then your contrapositive will also be false. Sometimes these get a little bit tricky to read because of the way that we flipped them and we've negated things in there. They just become a mess. And this is a great fact that is true, so that you don't really need to worry about whether or not your contrapositive is true or false. Just base it off of the original one that you have there. Okay, and again, all of them could be true. There's cases where that happens. More or less, those are like definitional type things. Those would be definitional type things. We could go back to the birds and the feathers. We could write all these statements with that, and they would all be true. All right, we got one last thing here, which is biconditional statements. A biconditional statement. Looking at the related conditionals, that last little conversation was about whether or not those conditionals can be true or false. Well, if you do run across a case where the converse and the original statement are both true, you can actually rewrite that as a biconditional statement. That's going to end up using the phrasing if and only if. That'll be used. You will end up dropping off the if at the very beginning. The then part is going to get substituted with if and only if, which can be abbreviated as IFF. So if you see that in the future, that is not a typo. That actually is just an abbreviation of if and only if. These biconditional statements work great for definitions. They work great for definitions. Okay, so let's take a look at example 4. If two lines intersect to form a right angle, so imagine that, two lines intersecting to form a right angle. Here, let's draw a picture. There's one line. To make a right angle, I want it to look like that. All right, so if two lines meet at a right angle, they are perpendicular. Yeah, they are. That's the definition of being perpendicular. Lines that meet to form a right angle, or lines that are at 90 degrees. Those are perpendicular. So we really have like a definition that's going on here. Now, if you do notice it as a definition, what would be a really good idea is to have the term in the hypothesis. Okay, so we're not going to be using the word if. We can take that out. We're just going to start with two lines are perpendicular. All right, two lines are perpendicular. So I still wanted to take the subject from the sentence, which is the two lines, but then I'm going to identify them as being perpendicular. I'll say two lines are perpendicular if and only if they intersect to form a right angle. All right, so I still got my subject here. Two lines are, there's my term, perpendicular, if and only if they intersect to form a right angle. All right, now, where that's coming from, once again, here is that the original statement that we had, like I drew the picture that fit the hypothesis, yeah, they turned out to be perpendicular. But you could rewrite it. You could say, if two lines are perpendicular, then they form a right angle, because that's the definition of it. That's the definition of it. But if you come across these cases where the original and the converse both work, it is best to go ahead and just change it into a biconditional statement. You do not have the word if in the front. You don't have the word then, but you will substitute it in with if and only if.
Later, blah.